The PCI Express bus, commonly called PCIe for short, is a high-speed serial interface used for connecting peripheral devices to the computer's motherboard. It was developed in the early 2000s to replace the old slower parallel interfaces such as PCI, PCIe, and AGP. Today, PCIe slots are widely available on modern devices, while the legacy interfaces are present only on older systems. PCI Express is used to connect components like graphics cards, solid-state drives, network cards, sound cards, and many others. A key feature of the PCI Express is the use of the so-called lanes. A lane is an individual data pathway consisting of two pairs of differential signaling wires, one for transmitting data and one for receiving. This structure allows the PCIe slots to support simultaneous bidirectional data transfer. Although PCIe is a serial interface, it achieves high bandwidth and high transfer speed by using multiple lanes in parallel for a single slot. These configurations, typically labeled as X1, X4, and X16, indicate the number of lanes allocated for the particular slot. While the PCI standard theoretically allows up to 32 lanes, such configurations are rare and primarily reserved for high-end servers and data centers, as they are impractical for consumer-grade devices. Since its initial release, the PCI Express has evolved through several revisions, each doubling the transfer speeds of its predecessor. Version 1 supported a data transfer rate of 250 MB per second per lane. The latest widely adopted version, the PCIe Gen 5, supports speeds up to 4 GB per second for a single lane. PCI Express 6 was introduced in 2022 and by using PAM4 modulation increases the speed up to 8 GB per second, but it is not yet available on any motherboard. PCI Express 7 specification is expected to be finalized later this year and aims to push speeds by fine-tuning channel parameters to decrease signal losses and improve power efficiency. Nevertheless, consumer devices using these newer revisions may not appear for several years, as for now, even devices using the PCIe Gen 5 are few and expensive. PCI Express slots come in several different sizes, corresponding to the maximum number of lanes that they are designed to support. The most common configurations are the full-sized X16 slot, the X4 slot, which is around half the length of the X16, and the X1 slot, which is around 1/4 the length of the X16. There is also an XA slot, but is less common on consumer motherboards. The PCIe standard allows devices with smaller physical connectors to function in larger slots, but the reverse is generally not possible, unless the slot is open-ended. However, in both cases, bandwidth will be reduced because not all lanes can be utilized. And this is where things get confusing, because the physical size of the slot does not always match the number of lanes it provides, as some of the necessary pins might be missing from the slot. For example, some X16 slots may only support X8 operation or X4 due to motherboard design or chipset limitations. Additionally, some slots might operate using an older PCIe version. Check your motherboard's manual to get accurate information about the capabilities of each slot. For laptops and compact devices, a mini PCIe slot was developed to accommodate low-profile cards. However, it has been largely replaced by the M.2 slot, which supports PCIe connectivity and is now commonly used for SSDs and network cards. The M.2 slot typically provides 4 lanes of PCI Express, enabling high-speed data transfer in compact form factor. The PCI Express bus was initially controlled by the NOR bridge, an integrated circuit on the motherboard which functioned as an intermediary between the CPU and the RAM and high-speed peripherals. Over time, the NOR bridge function was integrated into the CPU, enabling faster access to the memory and more direct communication between the processor and other components. On modern motherboards, some PCI Express slots are connected directly to the CPU, providing the fastest performance, while others connect through the chipset. Slots routed through the chipset are slightly slower due to the extra step in communication with the CPU. The chipset is typically linked to the CPU via 4 PCI Express lanes. This can be especially problematic for high-bandwidth devices like GPUs. Similarly, M.2 slots connect directly to the CPU and through the chipset. Typically, the fastest slots are positioned nearest to the CPU, but again, it's a good idea to check the motherboard's manual. One of the most valuable features of the PCI Express is its backwards compatibility. Devices designed for older PCI Express revisions can operate in newer slots, and newer standard devices can operate in older version slot. However, the connection will always operate at the lower speed of the two versions. Thanks to this feature, users can upgrade their configurations gradually without needing to replace all components at once. I hope you found this video helpful. Don't forget to like and subscribe, share your thoughts in the comments below, and feel free to check my other videos as well. Thank you for watching.